Hi everyone. Today I'm trying to explain about just about normal database fundamentals itself. I'll not go into very deep, but yeah, we'll get some normal idea. So, first thing first, actually there are two types of databases mainly. Uh, Wait 1 second. Yeah, we shall go to shapes. Yeah. So, one is SQL. I think you all might have known, and the other thing is NoSQL. So the main difference is like if you say SQL, mainly what can we say? Mainly it is something like it is like an Excel sheet. I mean, very strict columns. But if you see this, NoSQL, it's like our file structures, whatever you see in your Windows or Mac or Linux. So it's not fixed how many folders or how many files should be there in a single folder. We can create n number of files and number of folders, right? So we can take that as analogy here. So one thing, so at the start SQL was there. So let's say we are having some table. Let's take a table. uh, leave it, come and there. Let's leave it. Let's say, where is this? Okay, we'll take text. Let's say first, in SQL we are having one thing called customer name. Let's say there is a table which is having customer name and customer ID, right? In a similar way, we are having one more table which has customer ID, order, and order ID. Don't confuse here, there are 3 columns. Here also there are 2 columns. So actually we can remove this customer ID and we can keep this order and order ID in this first table itself. But let's say a customer is having many IDs, many orders. So we'll be having, we need to store many rows, and there will be a data, what we call it as data duplication. Like you will have customer name many times, only the order ID will be different. So to avoid that, what we have done, we have created 2 tables and we are keeping a foreign key called customer ID and we are referencing it. So this is good. This is what you will do in the traditional SQL, and yeah, it is good. But let's say we are our company has grown and our database has increased. What happens now? Now when you try to join these both tables, it becomes difficult because the data is large and processing will obviously become difficult. So instead of doing these joins, because joins are becoming difficult as the data is increasing, because the data will be across many databases, and doing join will be of course a high processing and high time taking thing. So what if we store something like customer name, let's say customer name, we store something like a document, let's say customer name, and one more thing we say, that is order details. let's say order details, and here in this let's create customer ID, order ID, or whatever details there might be. So this is something like dictionary, like, so if you know about map, there we can see dictionary is nothing but map. So in the map you can see, we know that it has some hashing in background, and every search will be easier. So whenever you try to whenever that lookup will be easier. So here, whenever we try to store like this for faster lookups, I mean, this format is stored generally in NoSQL. So for faster lookups, we generally do like this, and NoSQL is preferred that time. So, but I don't think this is whatever this dictionary part is, the dictionary kind of thing is not very good or not suggestible here, because orders or payments, whatever they are there, they should follow strict ASCII conditions. We shall learn about them in the further video. But the main, whatever we say, the main aim or strength of the SQL is ASCII properties. And in the longer run, if we need something like this in the faster lookups or something like this, we can use NoSQL, and where ASCII properties are not that important, like generally only reading, like not writing. In those cases, NoSQL is very much preferred. If we see the popular SQL databases, first thing everyone gets into mind is PostgreSDB, or we call it as PostgreSQL, and one more thing is MySQL, and other thing is SQL Server. Yeah, so, and again, coming to our NoSQL, you can see many databases are there, like, because here first, if we see document store, which generally stores JSON like documents. JSON like means something like nested dictionaries. This is what nested dictionaries. Okay, nested, yeah, we can say nested maps, not dictionaries, nothing but JSON. So for this, example is MongoDB, and yeah, we can see here. So examples are like that only. So yeah, one more thing will be key value store. So simply we can say, like, there are no nestings, like just you will be having key and you will be having value. Main and very good and very important database in the software industry, that is Redis. For the performance, mainly we use this for and yeah, there are many other things, so we shall learn about them in the future. So mainly if we see schema, for SQL it is fixed. We shall see differences, that's it. Schema for SQL, let's say first thing, for SQL it is fixed. But yeah, fixed means like we will do predefined columns. When you see NoSQL, it is flexible, that whatever we call it is dynamic. In some, let's say you might have getting doubt, like in Node.js application, in non-stack applications, like we generally define schema. So that part you might confuse, because in NoSQL, MongoDB is in NoSQL, and here also you are declaring schema. So it's generally a data without schema is full of chaos. It is a feature provided by MongoDB, flexibility. But if you do, let's say if you create like that only, and if you don't put any schema, that will be a very, and user, let's say a random user gave some random data, our data will be full of confusion. So from the application side, we'll always enforce some schema. And in future, let's say if you want to add one more, let's say one more field to the document, you can easily add, you can change the application code. But whereas if you want to add the same add an extra column in an SQL table, you need to write altering table code and all that time and all those things. All other previous entries should change. Either we need to keep a null value or whatever value we need to be there, but that doesn't happen in MySQL. No, sorry, Postgres. Sorry, MongoDB. You understood it, right? So now if we see scaling, if we see, you might have heard previously also, like if we want to do joins in the say, and if all those tables are like, if all the table data is in the same machine, that would be very easy. So vertical scaling, it can't do horizontal scaling. Horizontal scaling will be difficult, and yeah, because what? Because of why? Because of joins. And if we see NoSQL, even if you can do horizontal scaling also. Now if we see the relationships, generally relationships among tables, so we use joins, and generally in NoSQL, like there will be nothing. Generally we use denormalization. That means like we'll keep customer ID in every document. Like for each customer name, we'll be having multiple, like data duplication can happen. So for fastness, what we are doing, we are compromising the storage. That's it. So to get one, we need to leave one. That's it. That is a thumb rule followed everywhere. And if we see transactions, for SQL, the SQL itself provides strong ACID support. So mainly for payments and orders, all those things, people generally use it. And if you see the NoSQL, generally they provide eventual consistency. And in cases if we need strong consistency, like where they are write heavy things, like MongoDB can provide strong consistency also. So it depends. Like we can't say every time it provides eventual consistency only. We can say sometimes it can provide strong consistency also. Yeah. If we see query language support, for most of the SQL databases, you will have almost same language, but with very minimal changes. So we can say if you learn SQL language for Postgres, and with some very small changes, you can do this. You can use the same queries for the MySQL also. So that doesn't matter there. It is like standard. But in NoSQL, like it depends on DB. Language changes with DB. Now, yeah, where to use each one? Whenever you are doing complex queries involving joins, relationships, obviously we recommend to use SQL. Complex queries involving relationships, right? where you want to use this, what we call NoSQL, scalability matters. Wherever the scalability is mattering, you want flexibility. Your data is changing fast, and you can't predict how whatever features you want to use, something like that. Or in, let's say, in Instagram, or any social media, you are storing user data, or like user profile data. So in future you might need some more details, so in that place you can use this. And yeah, obviously one more thing is speed. Yeah, this is clear. Now let's see what are ACID properties. That's one of the important thing. ACID properties, if you see, A stands for atomicity. So atomicity, something we can call it as like complete or don't start. This is best. If it is completed, if it is started, then no in progress option, no pending option, sorry. So this is the support provided by SQL generally. They have something like locks. Not locks. Locks are not used here. But atomicity, like generally, they have some mechanism. We shall discuss it in the later videos. One example is like, let's say, uh, from account A, you are removing 100, and from to account B, you are adding those 100. So there will not be a case where A is debited but B is not credited, right? And if we see consistency, this is the part where most people confuse. Consistency has two meanings. In distributed systems, data across replicas is same. In distributed systems, it is correct. But in SQL, in ACID properties, it means following all constraints and rules correctly. Example, if rule says balance greater than equals to 0, and balance is 2, transaction with 10 rupees debit will be rejected. Third most important ACID property is isolation. This is isolation between transactions. This is the most important. Let's say mainly isolation between concurrent writes, right? Concurrent writes. This is important. Concurrent writes, like let's say both are updating plus 50 plus 50. Like let's say an account is having 100 rupees and there are two transactions saying that to increase 50 for both. So if they both try to increase, after two transactions it should be 200. It should not be either 150 or something else. So that is what isolation means. So when transaction A is working on a data column, it will lock it. Transaction B can't work on that data. It can only work when transaction A is completed and committed. Yeah. But always keeping locks can increase whatever we say, can increase the latency between two. Let's say first a write request and a read request came what we can say came at a time. What happens is, in this scenario, in lock scenario, either read should wait until write is completed or write should wait until read is completed. So here latency is increasing and data is also read wrong sometimes. So in that case what happens is, like, a new system was introduced, MVCC. Exact thing about it will be, we will search, I forgot the full form. MVCC, multi-version concurrency control. Yeah, multi-version concurrency control. What happens here is, like, when a read and write request comes at a time, or both two read requests come at a time but not two write requests. This is the main and important thing. When two write requests on the same data came, then it should obviously follow the locks. But in any other case except this case, what happens is, like, it creates versions of the same row. Let's say we are doing some write operation on the same row. What happens here is, this different versions of the same row is created, like copies are created, like snapshots are created and given to each transaction, and they individually work on the transaction. So in this case it is very easy, like latency is decreased and both can view at a time. So this is very useful. Now third most important thing is durability. Durability means what? Let's say system stores its state, does not lose its state on crashing. That is the simplest thing, or what we call simplest definition. Let's say a Postgres transaction is there, or SQL transaction is there, it is committed. Like, I mean, the data is changed. Let's say you change 100 rupees to 150 rupees, and it suddenly, either due to some manual intervention or due to some high traffic or something, the system was crashed. So after restarting, the data should be still 150 rupees, not 100 rupees. What is this? So what happens here is, whenever we get the committed acknowledgement from the DB side, what actually it should do is, like, before even sending the committed message, it should store the data in the hard disk or whatever No, but not in the random access memory. It should store in the hard disk. That is the main important one. No, hard disk is generally non. It is not general. It is hard disk is a non-volatile storage, so it should store there. So before giving us the update of commitment, it should store there and then it should give us the message of commit. But generally, writing data to disk, because the disk is a random access memory, it takes too much time, and commit acknowledgement will be very slow. So what happens here is it generally SQL uses something called write ahead log, or some people call it transaction log, or some other name. Many other names are there. What essentially it does is like, instead of writing data to disk in the first place, it writes a write ahead log. What happens there is like, write ahead logs are something called sequential writes, not random writes as data. So this sequential writes will be faster, and instead of generally what happens is like, if you change a certain cell from 100 to 150, it stores row with certain cell, a cell in a certain row change its value from this to x to y. So in like, it stores like a log. These are stored, and let's say even if it doesn't write to disk and it crashed in between, later after restarting the machine, it can, seeing the write ahead logs, it can, the data can again be what we call it, the data can be retrieved. So that's why people write ahead log, which is generally faster, and it decreases the latency for the commitment acknowledgement to the client side. So this is very important thing. So yeah, you might have yeah, this is what these are the fundamentals of databases. So we shall learn more about SQL versus NoSQL in the next video. Thank you.